first thing is transition metals are colored. Okay, that's pretty obvious. Everyone knows that. And we're going to talk about the reason why they're colored and what kind of colors do they have, and what determines what kind of color they're eventually going to have. Now, the first thing is I need to define what a metal complex is. Okay, that's the very first most basic thing. Okay, so what really is a metal complex? Now that's point number one. Now a metal complex is an ion formed. It's an ion which is formed when what happens? When a few things happen. When a metal ion, when ligands datively, they end up bonding with a central metal cation. So central metal cation. Now I'll explain all of this. Okay? So that's what a metal complex is. And then you have the other question, that what is a ligand? So ligand is that species that has lone pairs and is capable of forming dative bonds with a metal ion. So it's a species which can donate lone pairs. So it has lone pairs and can datively, and what it can do is can datively bond with a metal cation. So there are two definitions, and we're going to learn what this means. So the first thing is I'll explain what a metal complex is. Now, whenever a metal, a salt, or any compound of a metal dissolves, for example, if copper sulfate ends up dissolving, the copper sulfate ionic lattice, if it's aqueous, what will happen is that it will dissociate. And it will form copper 2 plus aqueous and SO4 2 minus aqueous. So visually, this is what goes on. Like if I just Google ionic salt dissolving, so visually speaking, something, which was a good diagram. I mean, this was a good diagram. I'll just copy this. So visually speaking, this is what actually goes on. So this is what actually goes on, that you had, so now you had an ionic lattice where you had a bunch of positive ions and you had a bunch of negative ions. So there were positive ions and negative ions, and positive ions, they were all attracted to each other. This is what an ionic lattice kind of looks like. So positive ions attracting negative ions attracting positive ions. When you mix it in water, the ions, they dissociate, they scatter. All the positive and negative ions, they dissociate because you're stirring them vigorously in water, and the ions, they scatter. And those same ions, they get surrounded by water molecules. So water molecules completely surround those ions once they're mixed, which is why they're not able to form the lattice back again. So if you dissolve NaCl, the ions, they get scattered and they dissociate. Okay, so this is the basic idea. But the thing is that when these ions are roaming around in water, when you have copper 2 plus, and this copper 2 plus is aqueous, what happens is that this copper 2 plus, imagine that it is floating around in water, then this copper 2 plus has 6 sides. And so it's got 6 sides, and there's so these are your axes. So these are all the sides of these are your X, Y, and Z axis. So those are your X, Y, and Z axis. Now, imagine this copper 2 plus ions, just like in this picture, it's floating around in water. Now, water is a highly polar molecule. So what happens with water is that the water molecule has lone pairs, and those lone pairs are going to be attracted. Those lone pairs are going to be attracted to these copper 2 plus ions. Water has these electrons which have a very strong partial negative charge density. The hydrogen has a slight positive charge. So all these water molecules and the lone pairs are going to be attracted to the copper 2 plus ions in water. So they're not just mixing, they're actually datively bonding together. The negative lone pairs are going to be attracted to copper 2 plus from all sides. Okay, is this clear? Umar, is this clear? Lisha, Anna, is this Sidra? Is this clear?
Sir, can you explain the 6 sides concept again?
नहीं 6 sides वाला?
Yes, sir.
6 sides होती है ना कि अगर let's say एक चीज मैं हूँ अगर तो अगर मैं let's say I am surrounded by water molecules, right? तो क्या एक top से there's going to be a water molecule on the top, there's going to be a water molecule at my bottom पे, ठीक है? One would be on the right side, one would be on the left side.
6 molecules can join.
So 6 molecules can join in. ठीक है? So it's a water molecule that's getting surrounded from all sides. So it's a copper 2 plus ion that's getting surrounded by water molecules from all sides. Okay? Clear about?
Yes, sir.
Okay, there's the negative lone pair, there's I said the hydrogens are positive. So you get something like this. The 6 sides, hopefully that is clear. Okay, you've got like if you're standing, you've got 6 sides. You got a front, you got a back, you got right side, left side, top, bottom. So imagine an ion that's floating around in water. That ion will not just be floating around, it would actually be attracting the water molecules. Why? Because water has negative lone pairs and the ion has a positive 2 charge. So a positive 2 charged ion will attract all these lone pairs from all the sides. Okay? And that is basically what your metal complex is. Okay? एक second. So that's what your complex is. Okay? This is what I stated over here, which is it's an ion that is formed when ligands datively bond with a central metal cation. And this thing over here, that's your ligand. Okay? The water molecule is known as your that thing, this water molecule, that's basically your That's basically your ligand. So when we talk about ligands, it's this thing. So that's your ligand. Okay, and this entire thing will have what charge? The copper is +2, the water molecules are neutral. So the overall thing, now this is one whole thing. Okay, now this is one thing. Copper 2+ is no longer separate. There's 6 water molecules that are sticking to it. So this whole thing, this entire thing is now an ion. Okay, that's your metal complex. And this entire whole thing will have a charge of +2. It's going to have a charge of +2 because copper was +2 and the water molecules were neutral. So if you add up all the charges, the overall thing will have a charge of +2. So what you need to do over here is you don't need to write the charge on this copper. But remember, copper was actually +2. The charge will now appear on the whole thing. Is that clear? And if I want, हाँ जी,
सर ligand वो होते हैं जो donate करते हैं
हाँ, ये ligand है ना जो आके उस metal ion के साथ attach होता है, ठीक है? So this is what is happening. That the copper ions are getting surrounded by 6. They're getting surrounded by 6 water molecules. And when they get surrounded by 6 water molecules, what actually happens is you got a copper now, and that's surrounded by 6 water molecules or joined up with 6 water molecules. And it's going to have square brackets around it. Okay, and it will overall have a charge of +2. Okay, that's a hexa aqua copper 2 complex. So naming is not that important. Hexa aqua copper 2 complex. Aqua simply means that it's got 6 water molecules. So the idea clear? Is this clear? The idea of what happens when a metal ion dissolves in water? Let's say water. Water is one example of a ligand. Okay, there are other examples of ligands as well. Lots of other examples. But water is one of the most important ligands because everything is kind of dissolved in water. So most of the time when you dissolve a metal ion and it forms a solution, the water molecules, they come in and they stick to the metal ion and they become one big complex ion. So is all clear? Everyone, is this clear? Nisha, is this clear?
So ये naming जो होती है यहाँ में like याद करने होगी ना सारे complexes.
Naming इतना important नहीं है. That's not important. It's I'm just writing a few names. It's a very generic naming. It's you don't really have to remember this. Hexa just means that there's 6 water molecules. Aqua means water. So this is a hexa aqua copper 2 complex. Is that clear?
Yes, sir.
So just remember, naming is not important. They're not going to ask you about naming. That's not in your course. Achha, so ligand is the one. Ligand is this one, the one that is donating lone pairs. Achha, so how many different ligands can you have? You can. So I'll just write some examples of ligands. One is water. Anything that's got lone pairs that can kind of act as a ligand. So water is one ligand because obviously it's got lone pairs. You've got NH3, that's another ligand because N has lone pairs. You've got CN-1 that also has OH-1, that's also a ligand. And similarly, the common ones, Cl-1, that can also act as a ligand. So you can have all these different different ligands, and that's your copper complex. So now based on this, and I'm going to use this, this copper 2 complex, this one specifically, this is a blue colored solution. Especially this one. This has a blue color. So whenever you see copper ions mixed in water, you're going to get a blue colored solution. And uski picture mein de deta hu, copper sulfate aqueous. You must have seen copper sulfate aqueous if you've ever been to a lab. So that's your typical blue colored solution. So I'll just so it's a very transparent, typical blue colored solution.
So,
हाँ.
सर जो ligand से related ये organic chemistry में है ना, जो जिस तरह से वो nitride हुआ NaCN HCN, तो और वो है, और उसके साथ जो non metals है जैसे chlorine और iodine वो आ सकते हैं?
नहीं, उसका ऑर्गेनिक केमिस्ट्री से इसका कोई ताल्लुक नहीं है. ठीक है. अच्छा, अब यहाँ से ना एक important चीज, there's one, अच्छा, so remember whatever I write on the board, that is the only thing that's important. ठीक है, and the questions are going to be exactly the same. So they're going to ask you about what happens when copper ions, they mix with water. This is the complex that's going to form. They might ask you to draw this, so you draw this. They might ask for the formula of this. They might ask for the color of this. Okay, so you just have to remember this. Apart from this, so anything that I write on the board, that's the only thing that's going to come in your exam. Now, there's a thing called Ligand exchange. Ligand exchange is that this water molecule, like if I add another ligand, these water molecules over here, they'll get replaced. So imagine this complex floating around, and so in any one of them, just so this water molecule over here, so this water molecule over here will be replaced. It's going to get knocked out, and it's going to get knocked out if you add some other ligand. So for example, if I add OH minus 1, right? Then the OH minus 1 is going to come in, and it's going to knock out these water molecules. Okay, so that is what is known as, that concept is known as ligand exchange. So we're gonna do some ligand exchange reactions, and there would be some other complexes that you have to remember as well. So here's one. Okay, let me draw this over here. So here's another one, and what will happen in this case is, okay, I take this blue colored solution, and what I do is I start adding NaOH to it. Okay, so that's what I'm doing. NaOH aqueous is added. Now, when you add NaOH aqueous to water, then obviously you're adding a lot of OH ions. So what's going to happen is that some of these, or it's going to simplify, I draw. Okay. Look at that, that is still fine. So some of these water molecules are going to be replaced by OH ions. So OH ions are going to come in. And these OH ions with their lone pairs will knock out a few of the water molecules. Okay, so OH ions have come in, and they've replaced some of the some of the water molecules. And they can replace more of them as well, but there's an issue. Usually it's just two of the water molecules. It could have been any two of the water molecules. It could have been an OH ion over here. It could have been over here. Any of the water molecules could have been replaced. So that results in the formation of a different complex, and that's CuOH. There are two OH, and there's 4 water molecules. Okay, there are 4 water molecules, and this thing is a solid because this thing is neutral. Copper was 2 plus. Okay, copper over here was 2 plus, and the OH over here are -1 and -1. So the whole thing has no charge. It's got an overall charge of 0. So this thing over here is your pale blue precipitate. It's a pale blue solid that is formed when you add NaOH to copper sulfate, or whenever you add NaOH to this blue colored solution, some of the water molecules are going to get knocked out and they're going to be replaced by OH ions. Sometimes this is also written as CuOH2. And since the precipitate is formed, this reaction is known as precipitation. Precipitation is what is taking place. And let me show you the color of this thing as well. So pale blue precipitate of so this is what your pale blue precipitate would kind of look like, I guess. I mean, this should be fine. Okay, just for reference, I'm adding the picture. So what has happened now is your blue color solution has turned into this pale blue precipitate of copper hydroxide by adding NaOH. Is this point clear? You clear?
So what's the name of this process called again?
This one is precipitation. I'm going to write Ligard Exchange. I'm going to explain Ligand Exchange. I'll write it on the board. But this one is the technical name for this is precipitation. Okay, there's another one where I'm going to write Ligand Exchange. But I'll write that. Achha, but is this clear? Is this clear? Is one clear? Sana, is this clear? Is this clear?
Yes, sir.
Achha, so you've got this thing going on now. And again, whatever I write on the board, that's the only thing that's coming in your exam. Another one is I said now there was one question. Why do you have only 2 OH ions coming in? The thing is that you can't have more than 2 OH ions. I mean, probability wise, you can't have more than 2 OH ions. The reason is that if there's a third OH ion, okay, let's say there's another. So let's say there's another OH ion coming in, and the complex now has 3 OH ions and it's got 3 water molecules left. So let's assume that another water molecule gets knocked out. So you now have 3 water molecules and you've got 3 OH ions. So what happens is that this entire thing now has a charge of -1. So it becomes negatively charged. Why would it become negatively charged? Because OH has a -1 charge and copper has a +2 charge. So if you have 3 OH ions, then the overall charge will be negative, right? And if it's negative, then it will start repelling any other OH ions. So you can't add too many OH ions because after a certain point, there's going to be too much repulsion. Pehle theek tha because there was attraction. like copper with 6 water molecules, it was positively charged. So if there were any OH ions that were nearby, they would get attracted to it, right? The OH ions will get attracted to this complex, and they'll come in and they'll knock out some of the water molecules, as long as it's positive. But as the molecule has more and more OH ions, as the ion has more and more OH ions, it becomes neutral, after which it stops attracting OH ions. And if a third OH ion comes in, then it becomes negatively charged. Then it's going to repel the OH ions. It's not going to keep them with itself. So there's going to be repulsion instead of attraction. So usually the reaction usually stops after 2 OH ions coming in. Is that clear as well?
Yes, sir.
अच्छा, अब ये कि बाकियों को clear है? Omar clear है? Saseeb clear है?
Yes, sir.
अच्छा, अब ये कि another Ligand exchange reaction, and that is when you add ammonia to it. Okay, this is what happens. Now, when you add ammonia to it, and let me copy the same. So when you add ammonia to this thing, now you can add ammonia to either one of them. You can add ammonia to from this point all the way to this point. One second. You can also convert this complex over here into this complex as well. I'm going to change the complex. Now you're adding NH3 aqueous. So you're adding NH3 aqueous. Now NH3 itself is a ligand. So what happens is that when you add NH3, all these water molecules they get knocked out. Whether it's OH ions or whether it's water molecules, they're going to start getting knocked out by NH3 molecules, and they'll be replaced by, and randomly from all sides, these water molecules will get knocked out. And ammonia ligands are going to take their place. So यहाँ पे ना there is ammonia. From all sides coming in and replacing. Now ammonia is neutral, so there's no element of repulsion. I mean, there's not going to be any repulsion. Like in OH ion, you were stuck with 2 OH ions, because after 2 OH ions, the overall thing got a negative charge. So that's why it did not attract any further OH ions. But with ammonia, you don't have an issue. All 6 of these ligands could be ammonia as well. So there's no limit to it. When you're adding ammonia, you keep adding ammonia, more and more ammonia molecules are going to come in, and they're going to replace they're going to knock out the other water molecule. It all depends on concentration. If ammonia has a higher concentration, they're going to knock out every one of those water molecules. So in this case, you're getting this complex. You've got Cu with 4 NH3s. And 2 water molecules. The charge does not change because water is neutral. NH3 is neutral. Copper is the only one that's +2. So overall thing will have a charge of.
Sir.
हाँ जी.
Sir, OH के केस में 2 था sir, of like 2 आ रहे थे H2O की जगह.
हाँ, इधर मैंने कहा कुछ भी हो सकता है. और you could have any number. उसके अंदर clear है ना कि 2 पे क्यों हम stuck हुए थे? कि 2 के
थोड़ा सा इशू था, तो आप प्लीज एक्सप्लेन कर सकते हैं OH2.
उसके अंदर मैं बता देता हूँ फिर से कि 2 के ऊपर क्यों stuck थे कि what would happen after 2 OH ions? न्यूट्रल हो जाता था क्योंकि copper is +2 and OH is -1, OH is -1. So if it is neutral, then it will stop attracting OH ions, right? समझ आइए क्योंकि नेगेटिव आयंस
Yes, sir.
और बल्कि अगर तीसरा OH ion आ भी जाएगा ना तो if there is a third OH ion, then it will become negatively charged, and if it's negatively charged, then it will तो फिर तो कोई attraction होगी. There's only going to be repulsion. Is that clear?
Yes.
तो वहां पे इशू था कि you can't add too many OH ions because then a lot of repulsion would start happening. हाँ यहाँ पे there's no element of repulsion because ammonia is neutral. वो जितने मर्जी आ जाए तो it's never going to, the ammonia molecule is not going to be repelled at any point. Is that clear?
Yes, sir.
तो यहाँ पे कि any number of NH3 or water molecules. So you could basically have all 6 of them being ammonia as well. So you can have 6 NH3s. Or you could have 1 NH3 and 5 water molecules as long as the total number is 6. ठीक है, is that clear? अच्छा, इसका जो color है, this one, this thing over here, this is a deep blue solution. तो ये मैं शो भी कर देता हूँ. So copper ammonia complex, it's a very dark blue, deep blue solution. तो यहाँ पे ना this is the change that you can see happening. Okay, you had a blue solution, copper was surrounded by water molecules. You started adding ammonia, so copper got surrounded by ammonia molecules, and that turned it into a different complex, and it eventually became a very deep blue or dark blue solution. So this is your deep blue solution, right? Is this clear? 3 solutions. Is this clear?
Yes.
So this is copper with any number of NH3s. I said then another one is that another one. So another one is you can add concentrated HCl to it as well. तो जगह खत्म हो गई, उसको इधर कर देते हैं. इधर से एक एरो बना लेते हैं, इसको थोड़ा सा इधर कर लें. अच्छा, so another thing that can happen is you can add same copper with water complex, ठीक है? And what you can do to it is so what you can do this time is you can add HCl, concentrated HCl. Now concentrated HCl has this Cl-1 ligand. Now the Cl-1 ligand, what it does is when it comes in, ठीक है, एक सेकंड रखना है. So what this concentrated Cl will do is that when it comes in, I've got copper 2 plus now, and it's going to get surrounded by Cl minus 1. So it gets surrounded by Cl minus 1. So there's a Cl minus 1 that's coming in from the top. There's a Cl minus 1 and its lone pair is getting attracted from the left side. There's a Cl minus 1 that's getting attracted from the bottom, and there's a Cl minus 1 that's getting attracted from the right side. And this entire thing will have a charge of -2. Okay, so this entire thing will have a charge of -2 because copper was the one in the middle that had a 2 plus charge, and all the others had Cl minus 1 charges. Achha, now this हाँ जी.
So इसके अंदर 4 है compared to like others.
हाँ, अब ये issue है कि why is it surrounded by just 4, not 6? पहले you had 6, right? You had a hexa complex. Okay, that meant 6. But now you've got a tetra complex. That means you just have 4. Tetra means 4. Reason is it depends on the size of the ligand. Okay, imagine karo that the ligand size is big, like it's very big. So you can't really fit a lot around them. Cl minus 1 is a lot bigger than NH3. What is the MR of NH3? That's 17. What is the MR of Cl minus 1? That's 35.5. So it's either 35 or 37. So Cl minus 1 is much bigger in size. It's a bigger ion. So imagine karo if you've got like a big ion, then you can't really fit a lot of them around it. Is that idea clear? You clear it? Is one clear? Siddha, is this clear? Alicia and Aseeb clear?
Yes, sir.
So that's the issue. So whenever you have bigger ligands, you can't really fit a lot of them around it. So the number will decrease. And this is a tetrachlorocopper 2 complex. So it's a tetra complex. It's so this is Cu with 4 Cls. Put square brackets around it. Remember, every time when you write a complex, you're going to put square brackets around it. And this entire thing has a charge of -2. So this is your CuCl4 -2 complex. And this thing over here has a greenish yellow. So it has a greenish yellow
Sir?
color. Haji.
Sir, इसमें +2 charge नहीं होगा?
Cl charge Cl है -1s.
Okay.
There's only one which is copper +2. Achha, iska na, the complexes are named after, I mean, these are known as octahedral complexes based on the shape. So this first one, that's an octahedral complex. So the first one is an octahedral complex. अच्छा चलो ठीक है, मेरा टाइम हो गया. तो चलो ठीक है, ये हम कंटिन्यू करते हैं. इसका कलर वो सारा पे ये से कंटिन्यू करेंगे. ठीक है, remember you just have to remember all of what is written on this board. ठीक है. चले, okay everyone.
Sir?
हाँ जी.
Sir, just one last question. Sir, बाकी क्या आपने कहा था कि tetra या hexa, तो इसका आपने octa लिखा होगा इसका ऊपर.
नहीं, octahedral वो shape है ना. वो याद है
Okay, sir.
AS पे shape होती थी, अगर वो 6 हर एक्सिस पे
हाँ,
बॉन्ड
6 bond पे.
तो उसकी बेसिस के ऊपर नेम हो. ऑक्टाहेड्रल कॉम्प्लेक्स है. ठीक है, वो कर लेते हैं, कल
Okay.
डिस्कस कर लेते हैं. ठीक है,
Okay, sir.
चले, ओके, अल्लाह हाफिज.